right, so let's choose color if I can. And this is dealing with a function and it's sine squared x cos x. And we want to show that that point lies in the graph. So if you substitute x into here and here, we should get root 3 over 8. So let's find out what is the function of pi over 6 in the g function. So it's sine squared pi over 6 times cos pi over 6. Now our triangle before, our 2 by 2 by 2, is 60. You split that up, that's 30. That's 1, that's root 3. So sine of 30 is a half, so over hypotenuse. Square that. And cos of 30 is adjacent over hypotenuse, root 3 over 2. That equals a quarter times root 3 over 2, which is root 3 over 8. Therefore, yes, pi over 6, root 3 over 8 lies on the graph. That point is on the graph. Okay. Give your answer in terms of g of x. Well, let's get the derivative of sine. Is that sine cubed x? So 3 times sine squared x. We've got power down by 1. Times by the derivative of sine x. The derivative of sine x is cos x. And then you can see sine squared x cos x right here, which equals 3 g of x. Right, so that is, just replace sine squared x cos x with g of x. 1 mark. Find the area enclosed by the function and the line. Okay, well, we need to get the integral from, well, actually, we want to go from 0 to 3x. Let's have a look at this. We've got sine x. And there's pi over 6 is here somewhere. Square that, sine squared, so we square that height. 1 squared is 1. It's going to be a very strange curve because the square root of a fraction is a fraction of a fraction goes under it. And cos x is cos x goes like this. So we're going to have a product of fraction of a fraction again. 1 of 0, it's going to go like this. Okay, it's going to be very similar. And we want that between 0 and root 3 over 8. Enclosed by the line and the y-axis. All right, then if we get if you get this rectangle and it's pi over 6 wide, and it's root 3 over 8 high, root 3 over 8, then you've got root 3 pi over 6/8 of 48. That's the rectangle. And if you take out the part underneath that integrates from 0 to pi over 6, if you take that away from that area, which is root 3 pi over 48, you will have the area between the y-axis and the line. So we want the integral of sine squared x cos x. And that's too hard to do. But we do know that if I took that 3, 1/3 of the derivative of sine cubed x is equal to g of x. If the derivative of sine cubed, if 1/3 of the derivative of sine cubed is 3, so if I take triple, if I take a third of g of x, of 3g of x, I will get a third of sine cubed x. So the integral will be 1/3 sine cubed x, 0 to pi on 6. Because if the derivative of sine cubed is g of x, then the integral of g of x is sine cubed x. So we want the integral of sine cubed, but I can only get the integral of 3. So if I multiply that by 3 and take 1/3 of that, then I've got 1/3 of sine cubed x. And put pi over 6 in there. Sine of pi over 6 is a half. And a half cubed is 1/8. So that's 1 over 24. So we've got root 3 pi over 48 minus 1 over 24. I'll make that 2 over 48. So we've got all over 48. It's root 3 pi minus 2. And that is the area.